Hey everybody. Okay, we're here. I see Melissa and Walker here. So we've got Walker wants to do chapter 10. Here, let me make Melissa a mod too. So let's add moderator right here. So we've got I know Melissa emailed me. Walker was working on one and then Walker got it solved. So great job, Walker, right there. I'm going to bring up my Pearson, which we do have access to right now. How's everyone doing today? Hey, Melissa. Hey, Walker. How are you both doing? Can you both hear and see me? That's always what I check, because every once in a while I'll start streaming. One time I was streaming the class and I was like, hey, everybody. And they were like, we can't see you, Brian. So we'll see if people can. Doing well. Looks like you guys can hear and see me. Good, but bored. I know. It's, I should be releasing a schedule. What we're doing is, so if anyone's watching this video, get excited. Because we should have Stat Lab kind of working again. I might just flat out buy it for the student. But I mentioned this yesterday. A lot of people, really Connor, really great guy, worked Stat Lab, and people are like, oh, Connor's great. He knows the material so well, and he really does. And so people are really excited that he'll probably be hosting Stat Lab on Zoom, and he's got a really good setup with his iPad, and he can show you what you're doing. So he can personally help students. If it works really well, I think we have about 3 to 4 hours the first week. We're going to try to get it going this week. And if that works really well, we'll try to put him to even more hours. We'll work with his schedule. A lot of people have free time right now. So whatever he wants to do, he might just be our main Stat Lab person. And so we're really excited about that. And big shout out to Connor right there. Stepping up and being like, yeah, I'd love to do Stat Lab. I'm getting the assignment pulled up as we speak. Melissa, I think it's from one of the recent ones. So I think this one, they're building a confidence interval, right? Is this from the quiz? So I'll pull it up right here. I think this is chapter 13, confidence intervals for proportions. And let's go to preview. No, I don't want to do that when I go to review. So I think, yeah, so the chapter 14 intervals ones, is it, for means? Oh, okay, cool. I was like, it feels like a confidence one. Okay. So, here we go. Wow, there's a lot of questions on this one. Okay, so here we go. I was getting it pulled up in the background while we were talking right there. So, I've got this right here. If anyone hops in and sees another one, I'll send out an announcement in a moment, but you can always check to see if I'm live, or you can review these and see what's going on. Let's just I can look this way at the screen. So tell me if you see it. Wait, was that it? That's the parking lot one. Wait. This is the one. We got it. We did it. Okay, let's see it. And I think I should be able to check my answers on it. Yeah, cool. Okay, let's work through this problem right here. And this one they try to trick you on a little bit. I mean, they try to do a lot of them, but let's see what's going on. So we've got a city parking garage wants to plan a structure with parking fees for a sample of 42 days. The average was this. Now, here's the big important thing. Please, 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 as you work problems, take notes. And we need to go here, take this problem here. We're going to bring it over to our Word document, our 10,000th Word document. We're going to drop this in right here, and we're going to talk about what it says. I wish I could wrap the text a little bit more, but that should be clear enough for everyone to see. So you see some keywords in here that are going to help us out, such as like random sample, which is the first condition. So we know we meet the first condition. We also see here 42. As soon as we see 42, we should know 42 is what. I want to see it in the chat. I know we only got a few people, but what is 42? We should know that, like, they took 42 days. You should be like, okay, that's got to be this. The quicker you get at identifying notation, the quicker these problems become. So we see 42 weekdays is how many days they collected. That is what. I know they only got a few people, but N, nice job. That is N. And then the daily fees on average they collected. I'll give you guys this one. We only got a few people here, so I'll give this one away. That is Y bar. And with a standard deviation of this. So the standard deviation, we're space penning everywhere. The standard deviation is going to be S. So if you notice here, we have a lot of what we need for a confidence interval. So we can probably build a confidence interval with this if we just know the percent confidence, and we can do a lot of different things with this. But we've identified all the notation they've given us, and we can go back to the problem right here. Oops, I had that open last. So we can go back to the problem right here. Okay, let's see if we meet the conditions. Condition 1, random. Condition 2, 10%. We've sampled less than 10% of all days. Good. The the sample's random. Condition 3 needs to be that we meet the nearly normal condition. And does it say that it's the cities with a random? Does it show us the shape of the data? Oh, what assumptions must you make? It doesn't say we've met them, but we have to assume that the data is random, that it's this, and then here's a trick. Why is that one not selected? Why is that one not selected? Why is that one not selected? It's a 10% condition, but it's done the wrong way. That is, it's not really the 10% condition, because the 10% condition should be we sample less than 10%. Sample less than 10%. So that's the key thing right here. And now we need a 99% confidence interval. Now this is where I think people start to make mistakes on these problems. Remember, this is one of the last things we did. So here's where I see mistakes start to happen. There's one more piece of notation, and I'm throwing 100,000 points off. We got to do it right here. We're doing 100,000 points if someone can tell me the other piece of notation that we need. It comes from sample size, but there's another piece of notation that you should figure out right now for this one sample t interval, and it comes from sample size. What is another piece of notation that we need to use? Any ideas in the chat for 100,000 points? It comes from, close. We do need to find the t, and I'll take that, Melissa, right there. We need to find the t, and every t has with it degrees of freedom. So you are correct. We are eventually going to find the t, but we need to know the degrees of freedom equals 41. Good answer right there. So we will use this to find the t. So let's go ahead and go to our website, stat distributions, and so I'll show you the site. I'll put it in the chat for those who watch the video. Is it going to load? Oh, there we go. Hopefully, I'm trying to get the streaming PC to work a little bit better, so hopefully it's working good and fine for everybody. Let's put this in the chat. Here is the website in the chat. And now we will see that we need to put in the degrees of freedom, which I think were 41. So we have 41 degrees of freedom. And then we want a 99% confidence interval. Now that's not a 99% confidence interval. This is right here. Notice that you want to do the between. There's other ways to make it, but I like to show it like it is a confidence interval. I like to show the middle area taken up right there. So we've got the 90% confidence interval, and we can easily change that to a 99, which the question wants. So this has now given us the t-score right here. This is the t-score, and let's show the formula. That was just to find the t-score in the following formula. The formula is y bar plus or minus t. This is the subscript n minus 1 degrees of freedom, s over square root of n. So notice how we solved each part of this problem right here. We identified the notation. We found the t-score we need for the interval. You have to find the exact t-score you need. You can't just use 2.5758, which is the z-score for this. Remember, the t-score is flattened down. And then we will just plug in the values here. So let's go through here. I'm going to erase each one of these and put in its actual value. So this would be 129. Now, all this goes away. That's just subscript because it tells you which t. We had to look it up. I think it was 2.701. We'll check that number in a moment. That's like in my mind right now, my mind's eye. And then s and n, if I could put them in. One of these days I'm going to make that thing go away and make it not appear. And let's check that t-score again because I am uncertain if I picked the right one. That's so close. That is so close to the right answer. It's a 2. Almost memorized it. It's 2 there. So this is going to be the mathematics for the interval. Let's put in the mathematics. So usually what I like to do is do square root of 42 to start. And then I'm going to copy that. I'm going to go 16 divided by this. This should be like 2.7 or 2.5. And then we're going to times that by 2.702. Now, I always ask people, what have I found at this point? I have found the margin of error. Take note that I solved everything right here, and that gives me the margin of error. So that's basically the whole interval. We can just add and subtract that. It's 6.67. So the answer would be 129. 129 plus or minus 6.67, which gives us the interval. We'll try to do this in our head right here. 129 122.33, and then, because that's when you subtract it, and then you would also get up to 135.67. The more mental math you do, the easier it gets. Just keep practicing your mental math, and then you could check it on the calculator. I think I've done these properly. We'll find out the hard way. So these are the intervals right here, calculated 122 and 135. Let's go put them in. 122.37 and 135.67. Explain in context what this interval means. I am 99% confident that the true mean earnings this parking garage will get daily is contained in the interval blank to blank. So let's check. I am 99% confident that the interval contains the mean. There we go. This looks right. Let me check the other one. And this says falls inside. There's 99% confidence that the interval contains the mean daily income. There's 99% confidence that the mean daily income will fall inside the interval. I'm hoping they're using correct statistical language because we don't like to say falls. It's that the interval contains it. It's not for all weekdays. Well, the daily income, no, it's the mean. So it's got to be A or D. And D, we don't like to say it falls in there. We like to say it contains it. Explain what it means in context. Let's do some tricky stuff right here. 99% of all samples of size 42 confidence intervals, 99% of all weekdays sampled have a daily income. No, it's not B. 99% of all weekdays have daily income that falls. No, it's for the mean. 99% of all samples of size 42 have a mean. No, I think it's going to be A. Let me read A again. 99% of all samples of size 42 produce intervals that contain. Yeah, that's it. I'll explain why. So when we make a confidence interval here, it's not about one interval. It's about the process of making intervals. The saying we like to say is, I'll use 99% confidence on it, 99% of 99% confidence intervals will contain the truth. So if you were to make, the sample size here doesn't really matter because it's just that when you make 99% confidence intervals, it's that if you were to keep making them, like the law of large numbers here, which we talk about in probability, if you were to keep making these intervals, 99% of your 99% confidence intervals would contain the truth. So 99% of all sample sizes 42 will produce intervals that contain the mean daily average. And look at that word contains, same word there. The consultant who advised the city on this project predicted the parking garage would have 137 based on your confidence interval. What do you think of this prediction? Is it in the interval? It's outside the interval. I don't think they're right. So the does not contain it. The consultant prediction is not too plausible. Let's check those answers. Oh no! Looks like we got the interval wrong. Let's check this. Did we get the interval wrong? Did I do my math wrong? So let's see right here. This one should be correct. That one was correct. We've confirmed that answer. Did I do my math wrong? Did I not square root something? This one is correct right here. Then it might be my interval is completely... No, that one's correct. Oh, how many decimals did it want? 2 decimals. And did I not round up or... It's my interval. That's what I get for doing mental math. That's what I get. Don't do mental math. Let me check all my numbers right here. Everything else theoretically looks correct. We could check other answers too. But we have a sample size of 42. Let's check the calculator again. I should pull out the TI. The TIs can just do these instantaneously. There's that. 16 divided by that is that. Times 2.702. It wanted a 99%, right? So then 129 plus that is this. And then 129 minus it is this. 122.33. Let's see, where's the mistake on this? Oh my gosh. You gotta be kidding me. Okay, that's right now. Is it this answer? Did I type it incorrectly? It should be. Well, there's a typo error. 135 point that. And then the days should not be dependent. There we go. Wow, I did that way too quick. There was one error that basically I just didn't see. Sorry. Melissa, oh no, have I lost everyone's faith in me? I was on a streak yesterday. I got everything right. The days should be independent of each other. So we have to assume basically it's random independent. And I'm looking at things from a pretty big distance. So can we do one more problem on this quiz before we jump to chapter 10? I think, so was it Maybe Walker was serious about it. I guess he really wants us to do chapter 10. This one right here was just a pure typo on this. And please tell me if you make typos like that. I do correct them because everyone can make a typo. It happens. And then I thought this said independent right here. So a company tested 11 brands of vanilla yogurt and found that the number of calories per serving were between this right here. So let's do it. A company tested... Have we seen that one yet? I like that problem a lot. I like this problem too. Those are easy. Here's the chip trial. Here we go. Okay. This one right here, you're best to use jump in. So this one can be really easily done with jump. Let's do the really easy way to do this. We're just going to copy the data right here and bring it over to jump. Now, when you get into jump, you want to open a new worksheet. And I can't state this enough, that you want to make sure you paste into this the right way. So, oh, we could do some chapter 10. I thought you were joking around, Walker. Well, don't worry. The question wording gets me every once in a while, and I don't know how to punch in my own numbers. I'm going to hit Control V right now, and I want you to notice that this is pasted properly. Do not paste with column names if a number goes up here. This is quantitative data, so you want to make sure you paste it in properly. Since it's blue, it's quantitative, and we've put this data in here properly now. So it wants us to do a histogram of it. So let's go here to Analyze Distribution and make a histogram. We could set it up the exact same way, but it's probably going to give us some insight here. So let's see which of these looks like it. We're going to make our histogram look identical to it. So it starts at 80, goes to 200, and has bin widths of 20. So I'm double-clicking that. 80 to 200, bin widths of 20. And there it is right there. And which one is it? Is it A, B, C, or D? The overall, yeah, I know. Oh, is it the sampling stuff, Walker? I think it's the sampling one. The sampling stuff is super tricky. Those questions, yeah, those are some of the trickiest. Yeah, those can be really I think our test is really straightforward. I can talk more about the test here in a moment. But yeah, the sampling stuff is probably, the questions are very, very wordy. I think it's probably the hardest quiz. People think the randomness quiz is the hardest, but the randomness is, if you know the way it works, I could tackle. I think I've done the sampling one 1,000 times. There's just a few where they're like, what do you think it might be? And yeah, if just put a specific, I know it's so, that's why one of the big reasons I lowered the sticker to a 95 is because it's really tough. It's a very tough one. Normal probability plot here. Normal probability plot can only go up and to the right. So there's only the possible answer of A. Yeah, 10 is sampling. I was mentioning it's only A or C. You are correct, Walker. A or C are the only possible answers. You can use jump to get this answer, but here's how it works. This is what we actually observe right here. Do you see how there's an observation in this one around, right here is the observation, around 170. And here, there's no gap. There's still an observation around 170, but there's not as big of a gap. And here is the point at 170. And the next observation at that is 157 and 156. So we go down here and we look, and those look to be the 157, 156, because look, there's no observations here in this area. If you go across this axis, does that make sense there, Melissa? That a normal probability plot can only go up and to the right. That's the only shape it takes. I mean, it can bend and stuff like that, but it can't go down. That's just not what they do. And so as we go through this right here, because think about this, the z-score of these would get higher, like the z-score would go up to 2. So as you go up this axis, the z-axis would go up. So that's why it always goes up and to the right, is because the higher the value of y, the higher the z-score of it. So because the mean of y would have a z-score of 0, and then things above it would have positive z-scores. So all you're doing is looking at the z-score of it, and if you notice, this one has a big gap here, and there should be nothing even at 140, but we have things at and above 140. So the answer has to be A. So if you just kind of look at how it works, where all you're doing is looking at the values of the y right here, you can take these values and correlate them to your y. That's the 171 right there. And then right here, you'll see we have the 57. The 57 is this value, and the 56 is this value. They're very, very close. And so that should be right there. Are the assumptions met? The assumptions and conditions are condition 1, random, condition 2, 10%, and condition 3, nearly normal. And that's pretty good. That's a pretty straight, nearly normal or normal probability plot. So we're pretty good on that. So I think, did it say it's random? They don't say it's random. I don't say it's random. A company tested 11 brands of yogurt and found Did you get into jump right now? Were you able to get into jump for that part? They don't say it's random, and I hate that. Oh, wait. Oh, my gosh. Wow. I'm really far away from this monitor right now. Like, I can literally put my hand out all the way, and I'm not touching the monitor. If you hear this. Like, I'm super far away from it, and everyone knows I'm blind. So if you come to office hours, I can't see anything. So you see me squinting at the monitor all the time. But it does say random. Good. That means the randomness condition is met. Randomness condition is met. The normal probability plot is relatively straight. Good. So this one's eliminated here because it is straight, and the randomness condition is met. We've narrowed it down to A and C. The histogram is roughly unimodal and symmetric. Yeah. That's not really a strong second peak. Is that the only difference? Yeah, it's really, you want to look at this right here. And this is where we see a small mode and a small mode. Don't worry, you don't have to know that exactly. But a good normal probability plot, if you remember from earlier in class, chapter 5, is one that goes up and to the right. It's straight. It's straight. It's normal. If it's not straight, it's not normal. So that's what we have going on right there. We should be good. And then we can build our 95% confidence interval. And let's go look at that. Here's our 95% confidence interval. If it asks for a different one, you can go here and go to confidence interval and go to other, or 99, sure. And you can put in the level of confidence you want. So our answer is going to be right here for the 95% confidence interval, and it's 116.65. And then the other one, jump output, where are you at? The other one is 147.35. There we go. That should do it right there if I can put numbers in the proper order. A diet guide claims that you will get an average of 130 calories from a serving of vanilla yogurt. What does the confidence interval indicate about this claim? It's believable. Yeah, it's completely inside of there. The confidence interval is contains it. So the claim is supported by the evidence. Let me look at my interval again. So 116 to 147. Oh, no. That'll make it wrong. Check answer. 100%. That's what I like to see. So yeah, that's little, you just got to make sure you read them very, very carefully and watch for every word. It's random right here because it says random. And then be careful. This is not really bimodal, and I'll show you why. I know a lot of people might be looking at that and be like, it looks bimodal. But remember, the bins can trick you. So if we have this in jump right here, we can do this, and you can see it's really just got kind of one modal area. I would say around here is the mode, so it's probably with just a small sample. What is it currently working, Melissa? Do you have the data into jump? I can tell you what to do right now. Do you have it working, or do you still have issues? And feel free to ask, and we will fix it. What issues are there, if any? And then Walker, do you have a personal problem you want me to do on chapter 10? I like the parent one with the PTA thing. That one's a fun one. It's really good. Yeah, if you have any issues, like if you're trying to get the data into jump, if you want to not copy paste it, just go to jump, open a new sheet inside of jump. And so don't worry about copy pasting. Just have the new sheet here, and then just type in the numbers. So just type in 129, 157, and make sure you just type in the numbers. It's easier to copy paste it in, but if you do this right here, make sure you get all the numbers in the right order. So how's that looking? Are you getting the numbers in? Do you have the numbers in? Are you wondering about just an overview? Yeah, we'll go look at a chapter 10 question here in a moment. Melissa, how are you doing? I have my history. So you have your histogram now? Now that you have your histogram, so you've got the histogram. So if you want to know what distribution it is, and you have the graphic, then the answer for the 95% confidence interval should be here, but you can also go to confidence intervals. Wrong button. You can go here to confidence intervals, and you can create whatever percent confidence you want. So you can create, however, but how do you get to put in the data the graphic gives you? I am confused. Are you saying, tell me here, I'm gonna ask here, I'm gonna do it from the start. You ready? So let's open up a new sheet inside of jump. So we're gonna go to File, New, Data Table. So that's step 1. We have a new data table open. That's step 1, new data table open. Then we're going to click here, and we're going to go to copy to clipboard right here. This is step 2, copy to clipboard. Are you following along with me right now? Does everything make sense? Do you have the new tab open, and do you have ready to copy? So, okay, and then we go here, and it looks like you're on the histogram. So then we paste our data in, look like we have that right there. Then we go to distribution, we double click, and we go here. I'm going to go to stack, it's easier to look at. Now, to change the way the histogram looks, you might be on this step, you double click this axis right here, and then you look at their axis. So you need to look and say that this goes from 80 to 200, and the bin widths are 20. So we're going to go from 80, and I'm hitting tab, 200, and then the bin widths are 20. And if you look, here's the preview of it. Looks just like this over here. So we click OK, and now it looks just like it. So now we have our histogram. We can figure out which histogram we're using. You added in numbers after you got the histogram. Oh, and then does that make sense where I clicked here and then I changed the bin widths to be, 80 to 200 by 20. I'm going to make this scale right here look just like this scale. Are you on this step and have you completed this step right here? Does that make sense right there? Cool. And now, once you do this, all it wants really is the 95% confidential and the right normal quantile plot. You can also go here and go to normal quantile plot. And if you notice, theirs looks a little bit different. That's why I've always thought it's a little bit harder to look at this one right here. Like jumps looks a little bit different. We stretch it out, it's going to look more like ours. But it's just the way they plot theirs is a tiny bit different. So I've always thought it's hard to tell because for some reason they make theirs a tiny bit different. But always remember this. Let's use the way right here. To know which normal quantile plot it is, we're going to look at the value like 171. We know that these must always go up and to the right. So we see here, this is 171 if you trace over. And then this right here, we need a 157. Do you see how 157 would be about that point right there? That's 157. And then over here, there is no 157. If you trace across, there is no 157. That area is blank. Where was the axis? Which part are you stuck on right now? I'm trying to see. Are you down to the confidence interval part? Are you on which part are you on? Like, choose normal probability, or are you down to the confidence interval? And if you're clicking on the axis, if you're watching, that might be the question. You can click on this axis right here. It's this right here. You just double click on this right here. And then you put in 80 and 200 and go by 20. So that's got that right there. And then the confidence interval. Did you get it, Melissa? How'd that work? We might hop over to Walker's questions here. Let's see. And the test scores are looking pretty good for those who are taking the test. It's a little like the grades look to be in the high 70s right now, but here's the biggest thing is the quizzes. I can't state enough to do the quizzes because they're a huge part of your grade. And so I've seen some people who have made like a 70, but then they get pulled up to an 85. Putting in the numbers, yep, here, I'll pull that back up. You want to click right here, Melissa. So you have the graphic. Click right here. So you want to double click on this axis right here. Do you see this axis right here? So you want to double click on this, and then this will bring up this screen right here. And this will make your histogram look just like theirs. So then you want to put 80 into here, and then you want to put 20 into there. So you just double click this right here, and then you put in 80, 200, and 20 right there. 20 goes in the increment part. So in the increment part, the minimum will be 80, the maximum will be 200, and then the increment will be 20. I think as long as yours looks like mine, check to make sure in your problem that they have the same numbers. So make sure it's going from like 80 to 200 by 20. I don't know if every problem looks exactly like that. You got it? Okay, great job, Melissa. So yeah, make sure your problem looks like that, and then you should get a histogram that looks like that. Let's see here. Is this the homework, Walker? I think, hey, Carson, good to see you. Love people jumping in the chat, saying hey. So let's see. Let's pull this down right here. We'll do the homework because the homework's still open. So, love it. I'm going to start sending out regular hours. And as I said, we're going to have Stat Lab start going up. Which one is? Oh, the amusement park one. Okay. So the amusement park one, you got it. Awesome job. An amusement park has a new roller coaster. It's so popular, people are waiting 3 hours to ride a 2-minute ride. Concerned about how patrons who paid a large amount to enter the park think about the rides, feel about this. They survey every person as they exit the park. If they survey every person who exits the park, what would this be? You guys are too funny in the chat. If they survey, also, can we have 2 pieces of scratch paper? Yeah, show them both, just and show front, back. Just be like, here's my scratch paper, and we'll be able to tell. You should be good. And remember, once again, don't worry. I've had some people really worried because they made like a 75 or a 70. If you make a 75, you've actually made an 87.5. If you make a 70, you've made an 85. Do remember, do your quizzes. It's the best thing. Well, no. Wait, careful. They're surveying every single person as they exit the park. They'll speak to everybody. Now, if they were to go out first thing in the morning and first speak to the people who first enter the park, that would be convenience. So if they speak to the people as they enter the park, that would be convenience. But not everybody. The key word here is they're going to speak to everybody. Does that make sense, Walker? They're going to speak to everybody as they enter the park. Every single person. A census, you're right. This would be a census right here because they're talking to every single person. What is the sample frame? So you have to ask yourself, these are the people they have access to. Make sure to know your definitions. The sample frame are the people they would have access to, so you have to think. If they're going to talk to everybody, they're going to have access to everybody. So they're going to have all patrons who go to the park. It's not all people who go to amusement parks. So that's the people they would have access to. When you read this question, change sampling frame to what are the people they have access to. Does that make sense? Remember what sampling frame is. Yep. What are the people they have access to? That's the way you should read it. Because sampling frame, what does that mean? It's the people they'd have access to talk to. So it's the people they could theoretically speak to. Is the sample likely to be representative? That's our goal with sampling. Of the population of interest. Population of interest is just the people we want to understand. And the answer is yes. If you try to speak to everybody and you get everyone, then yeah. Sample. And we want to understand the people at the park. So an amusement park, concerned about patrons. Who do they want to understand? So this question actually has a second part to it. Sample frame is what you pull the sample from, correct? Kind of, yes. Your sample must come from your sample frame because your sample frame are the people or things you have access to. So your sample would come from your sampling frame. So your sample is what you get data on. Your sampling frame is what you have access to. So you can only get data on things you have access to. This problem right here, the difference between A and D, is actually the definition of the population. The population is the things we want to understand. The sampling frame is what we have access to. The sample is what we get data on. So if you notice, A is saying the population is who. A is saying the population is who. And I've kind of got it all highlighted right now. In answer A, it's defining the population as who. Because it wants to say, is this representative of the population? Well, the real part of this question is what is the population? Because D gives a different population. The population we are interested in is everybody who is what? Who knows in the chat? Any answers? Everyone in the park, you're right. Where D incorrectly states that the population would be people in line. So that's the key part to that. What members of the population are omitted? No members, because it's a census. The census gets everybody. We could do another version of this one right here. It can get tricky. More versions. So show similar question. They sample every 20th. You can just, your eyes can go right to 20th. And yep. So we go right to 20th. And what do we see? 20th is a systematic sample. What is the sampling frame? Concerned about, starting with a random male. And then they're going to talk to every 20th male. So the sampling frame would only be, are they talking to people on the line? Or as they exit the park? So it'd be male patrons of the park. You guys got it. Nice job in the chat. 10,000 points for those answers. Keep those answers coming. This would be, they would only be able to speak to male patrons of the park. Does everyone notice how I'm converting this? When I talk about sampling frame, I'm going to say they're only going to have access to talking to male patrons. Now, it doesn't mean that they would talk to all male patrons. It just means these are the people they have access to. So nice job, Walker. So you said the curve is with the quizzes right now, and we'll keep looking at if the grades are crazy. Who knows? But we're gonna update as we go. Is that same for me since I already took it? Yeah. So the original test, if you took, and there's very few people, Melissa, you're in a very select group. Here's the great news. And it only applies to a few people because we're just doing this as we do it. The original test, if you took it, since it's just an original test, you got that opportunity, which we thought we'd still be able to somehow give the test. But the good news is by taking the online version, you cannot hurt your grade. So you cannot lower your grade in any way. So if I was in your position, I would take the online version. It can only help your grade. And in the online version, you get the added benefit of the average. So make sure, and I hope I communicate that to everybody, but make sure you know that your grade can only be improved by taking the online version. That is the one we will average. So go ahead and take the online version, and it can only help your grade. I know, and that morning test, I think in the afternoon, I mean, how many did we have, Melissa? I think we had like 15 out of 1,400 students, or maybe 16. Like there was very few. And then in the afternoon, I think 2 showed up. So like around 1% had taken the test. So we try to treat everyone as fairly as possible. And I'd hate for someone to be like, oh, they get to take the test twice. Well, I do think the grades, from what I'm seeing about the online test right now, I think the grades will be a little bit higher. Remember, the big thing is that we're averaging your quiz average into it. That's a huge help. So do remember that if you have 100 on your quiz average, you only need a 60 on the online test to make an 80. If you want to make an A, you only need an 80. So make sure to work. They're saying the answer is A. Is it likely to be representative? No way. So it's not likely to be representative of everyone in the park. You guys got it. What members of the population are omitted? Female patrons. Non-males. So non-males are omitted. Each examining each of the following questions for bias. So this is response bias right here. We've got different types of bias. We've got response bias. We've got undercoverage bias. And we've got non-response bias. So I've done this one so many times. Maybe we'll skip it. But should companies that promote smoking be liable? So the answer is biased towards yes, because the word promotes teen smoking. They should just ask, should companies be responsible to help pay for the cost? I think that's it. Great job. So they should just be like, should companies help pay for the cost of smoking? Nice job answering in the chat. Given that 16-year-olds are 10,000 points right there, Carson. Given that 16-year-olds are old enough to drive, is it fair to set the gambling age to 18? Or they do change the age. So this one is biased towards yes. These are all response bias. Yep. Because of the way it's worded, it can push someone towards a certain bias in their response to say like, yeah, they should do that. The question is biased towards yes. There we go. Oh, no. It's biased towards no, because you're trying to say, no, wait. It is biased towards yes. Better question would be, given that 16-year-olds are old enough to drive. Wait a minute here. The question is biased towards no because of the preamble. See, this is what the question should be set to. It should be set to, do you think the gambling age should be set to 18? The way it's worded, is it fair? So it's not saying, should we set the gambling age to 16, 18? It's saying, is it fair? And then someone's like, no, that's not fair. So the answer is biased towards no. It's totally this one. That's so tricky wording. It's so tricky. I know, it almost tricked me, because the question is biased towards no, because they're not asking, should we set the gambling age to 18? The question is it fair that the gambling age is 18? You have to be very, very careful. And that's where you get tricked right there, because, I'm lucky, because it says a better question would be, and then it gave the same bias. So when I looked at this right here, and I was tricked because of the yes, because I read it wrong. Yeah, I know, it's so tricky. Oh, Melissa was on the quizzes right there. And if you hit the live button, if you see a button that says live, Melissa, you might be a little bit behind. Click the live button. It'll be like below me right here. And that'll have you where you're watching me live. And so there's only like a 2 or 3 second delay then. So that way, if you ask a question or if I ask one, it's like pretty instantaneous. And I like this a lot. We'll do like maybe another one. Carson, do you have any questions? Melissa, feel free to ask any questions. CEO question. Okay, we'll do this right. To find the public's views on obesity, researchers wait outside a fast food restaurant. They had randomly selected from a list of such establishments. Now this one's a bit weird because, and let's review this right here. They're going to take one fast food restaurant, and they stopped every 5th person. So it's got a lot of bias. How long are you live for? Probably maybe another hour. As long as there's people here talking to me, I definitely stay live. Awesome, Carson. Just keep being like, I'm still here. Like if no one's here, I might leave. But I'm also going to set up times so people know when to find me, because I kind of just went live today and a few people had emailed. So I was like, I'll go live at 3, and they're like, I'll be there. And I was like, good, let's do it. So the population is every person or thing. We're hearing B in the chat. All people except those who work at Nah, wait, the population is everyone when they want to understand. So to find the public's views on obesity. So they want the public's views on obesity. So you guys are awesome. So it's going to be people, if I'm not mistaken. Good. So remember, when we talk about the population, it's all things we want to understand. So you have to ask yourself, who do we want to understand? And you have to say, okay, we want to understand people. So always define the word and then kind of say it like, who do I want to understand? That's the population. They want to understand the public's views on obesity. We want to understand people, the public. So then we identify that it's people by saying the population is the things or people we want to understand. We want to understand the public. So we got that one right there. The parameter of interest is what we want to understand. They're using the long version of it right here, the population parameter of interest. So the parameter of interest is every person or thing we want to get information on. So the parameter of interest is every person or thing we want info on. Oh my gosh, my brain just broke as I was making the screen bigger. The parameter of interest is what we want to understand. So they want to understand the views of people about obesity. They want to understand... They want to understand views on obesity. I wish they were more specific, but it looks to be the proportion of people. Let me check this. Proportion of people who think obesity is a problem. Proportion who think so this is technically like P and this is Q, but they're both pretty much the same. There might be saying C in the chat. They want to understand the views of people on obesity, and I wish it said they ask people if they think obesity is a serious problem, but that looks to be the question they're asking. So they want to understand the views of people on obesity. The sampling frame, once again, the people or things they have access to. And they did choose this from a list of fast food establishments. So it's not going to be every 5th person. That's the sample. It's people who think obesity is a serious problem. That's just like a response. That's not, it's kind of related to the parameter. All people except those who work at fast food restaurants. No, because people could work at it. So it's got to be this right here. Boom. They want to understand the public's views, and the public would also be people who work at fast food restaurants. I mean, you might be like, well, they wouldn't come out of that one. Maybe they work at a different one. So there you go. The sample are going to be every 5th person they talk to. I think this is pretty obvious. We got the population right here. This is the sample frame. I don't think we've seen sample frame yet, but every person they could theoretically talk to would be any restaurant they had on the list and anyone leaving that restaurant. So they could have theoretically spoken to any of those people, but the sample is going to be, I want that to go away right there. The sample is going to be every 5th person leaving the restaurant they chose. So there we go right there. It spun a while, it scared me. And we continue on here. The sampling method, this is where it gets tricky. Yeah, it's a good review right here. It's just a good review on, just so you know, I wear my... That's awesome. Yeah, dude, totally. That Rugrats sweatshirt is awesome, Carson. Man, I'm wearing Rick and Morty today. I got my Szechuan sauce Rick and Morty shirt on right now. Rick and Morty. And I got Rick and Morty meets what's his name? Grim Adventures of Billy and Mandy. So I got that picture right there. Morty's not too happy about meeting the Reaper, Grim Reaper from Grim Adventures of Billy and Mandy. Freaking out a little bit. Went to the wrong dimension. I'm picking Rick. Oh man, good memories right there. The sampling method includes whether or not randomization was employed. It is systematic. Yeah, so we're good. It's systematic, right? Do I already answer systematic? It's every fifth. I mean, every time I think of every fifth, it's systematic. Cool. Systematic is random, so it should be good there. Any potential sources of bias? Oh, this is where I get scared. These are the what are you talking about? My piercing questions. Since they interviewed people just left 5 years, touched on their opinions about obesity may be different from the population in general. Plausible answer. Response bias is studies conducted in such a way to achieve a desired outcome that, no, I don't think so. Non-response bias, some people leaving the restaurant may not respond to the interview. All of these are possible, but I really think it's undercoverage. Yeah, I'm thinking undercoverage too, because since they interviewed, think about this. I think this one's more obvious the more I look at it. If you were to go to a fast food restaurant, do you think the people's views at fast food restaurants would differ from those who don't go to fast food restaurants? Like, imagine someone's like, I never eat fast food. Then they could not possibly be sampled. They're out of your sample frame. So if you had people who just never eat fast food, I would think they would have different views. And that's the definition of undercoverage, is when the people you don't have access to, like you say, we're going to go to fast food restaurants and talk to people about obesity. And you'd be like, well, who do you want to understand? And you're like, everybody. And you're like, well, what about the people who don't go to fast food restaurants? You're undercovering them. So we're going to cross our fingers here, as we always do. And of course, it's correct. But yeah, because some of these are also plausible. But the most obvious one should be that we are undercovering people who don't go to fast food restaurants. So if you just go to fast food restaurants, you're only going to get the views of people who go to fast food restaurants. And then that's not representative of the general population. That representative word is key right there. Does that, Walker, help out? Do you have any other questions on... We pretty much did the whole thing right here. Really good practice. What other things do you guys want to know about? Like I said, the test is going really well. Sorry for there's a few hiccups this morning. I woke up to people being like, test is not working. There's issues. And I'm so glad that people emailed me and kind of... anytime people have problems, I've answered probably 100 emails today already. So that's why I've been kind of... A lot of days I'm answering a lot of emails. It's crazy times, but I appreciate it. And I always want people to know to email me. And I really appreciate people coming on here and like interacting and asking questions. If you're in the chat right now, if you're watching, just feel free to ask a question. We've got 5 viewers, so we probably got some other people in here. If you are watching, just be like, Brian, I don't know how to do this problem. Or Brian, how do I solve this right here? How are we doing on the analytics? And I'm going to send out a schedule. We've been bouncing up and down between 3 and 5 people. So I might get online later tonight and maybe answer more questions. Maybe I'll do like late night streams. Apparently, but let's do a problem like the light bulb one. Which one's the light bulb one? Is that what chapter is that on? Wow, how do I not know that? Is it chapter 14? We'll do it here. How does the light bulb problem go? And I agree, good practice. Thank you, Walker. I mean, big light bulb. You cracked me up there, Carson. I have no idea. I do not know what that means. You know what? I should really make it a thing today to get the Twitch going. Except here's the thing. You know what I'm going to do? I might try to make it that we do Twitch tomorrow night. Because you know what I'm going to do? We should end class and have the Twitch stream right after class. Because what would be better than on your first stream? Because there's a big thing on how analytics work. Like if they're going to show off a channel... So, Carson knows how to do Twitch? Carson. Because think about this, Carson. Let's talk about that for us, and then we'll do the light bulb problem. If you start up your Twitch channel, that's awesome, Carson. We could mention your stream in the chat, too. Be like, hey, if you want, watch Carson's. And I think Melissa's got a question here, too. But, all those kids lighting you up. I should get Fortnite on here and start playing it. I need, like, a more fancy layout, but I've got the green screen, so we'll start doing that soon. But... Here we'll do the light bulb problem, then we'll do Melissa's question. But what do you guys think of this plan? After class tomorrow, we'll go over to Twitch and we'll do a stream on Twitch, and we'll just do like a first like solving problems, and we'll try to have a really strong first Twitch stream. And if we could get like 100 people watching that, then that might be really good, and we'll try to utilize that more. We could maybe do that, Carson. If we get the Twitch thing going, I wonder if they'll let me do that. I have never played Fortnite. I played FPS, but I'm probably gonna get lit up in Fortnite. So where's it goes? And there's no money type. Yeah, you're talking about the. Are you talking about the poker one? On the. Melissa, are you talking about the one on the Quizlet? And where's the light bulb problem again, Walker? Is that a confidence roll problem? Let me pull up. Melissa's got a question that we're gonna start doing. We took our little tiny break right here, and then Carson has a question too, or Walker. Do you remember where that light bulb problem is at? We did it in class one day. Did I make it up? What was the light bulb problem? There's no light bulb going off. So while you try to remind me of the light bulb problem, where it was the problem? Oh yeah, that's probability chapter. Yeah, we can do that next. Yeah, here we'll do Melissa's problem. Oh, I know which one that is now. It's you buy the package of light bulb. Totally, okay, I know what it is. We, yeah, 1 out of 5. Cool, we will do that next. Okay, we will do that. The one that has like the categories you have to cancel out and group together, that was a lot of numbers. Are you talking about the one on the test, Melissa? Are you talking about the test one? Here, I'll do, while you explain a little bit more, Melissa. I think you're talking about the test one, right? The poke, oh, isn't it the practice test, right? Or maybe the poker one. So I'm going to do the light bulb one here, and then we'll do the other question next. Okay. So what we have, and I just want everyone to think, I'm going to do the most horrible drawing. Oh, it's on the practice test. Okay, I'll pull up the practice test next. I'm going to do the most horrible drawing of a light bulb ever. Oh, that almost looks like an LED light bulb. I almost got it. One of those fancy LED light bulbs up here. Whoa, we almost did it. Okay. So we're doing the light bulb problem right here. That's about the best I can draw, and I'm actually kind of proud of that. It's kind of sad. It was meant to look like a regular light bulb, and then it turned into one of those fancy LED ones. So what we have here is the probability of working. So let's go right here. Probability working is equal to 70%. And then we have here the probability of not working. We're going to do a second light bulb here, very small one. It's about the best I can draw. And we're going to put like a crack and just like, it's all broken. This is the probability of broken. So the probability of broken is what? So when you buy a light bulb, either hot air totally looks like that, doesn't it? Your light bulb either works or it doesn't work. So the probability the light bulb works is 70%, and the probability it doesn't work. No, my drawings are so horrible. The probability that it works is 70%, the probability that it doesn't work. So works, broken. And either works or it does not work. Yeah, you're right. The probability it works or doesn't work. So the probability it works is 70%. The probability it doesn't work is 30%. Okay, so you're going to buy a pack of 6 light bulbs. So when you buy this pack of 6 light bulbs, they come in like this, and we're going to do an overhead view right here of the light bulbs. So you're one of those people who just doesn't want to go to the store. Like you, especially in these times. And you're like, okay, I want to buy my 6 light bulbs, and my 6 light bulbs work. So you're like, well, what's the probability that at least one of my light bulbs is broken? I hate to say it, with these numbers, you probably have at least one broken light bulb. These numbers are working against you. I want everyone to think that if I told you one of these, like, what is a flavor you hate, Walker? What is a flavor like? Maybe it's like vanilla or strawberry or caramel or hazelnut or cinnamon or pistachio. Is there any flavor you're like, oh man, I don't like that. That's like, or like mint. Oh, I love mint. Mint and caramel. One of these are all cookies. And we could change this question right now. And what's your favorite flavor, Walker? Like, I'm going to go with, so we got down here, mint caramel. So maybe we'll go with chocolate up here. So you hate Thin Mints? Oh no. So we got here mint caramel. And we've got here chocolate. So I think chocolate. So, okay. So, Walker, you're just so hungry. There's a plate of cookies right here. And it's kind of an infinite plate of cookies. Don't worry, it's not like 70% of these cookies are chocolate. It's like I baked a whole bunch of cookies. infinite, basically. Like there's infinite light bulbs out there. Not really, but there's a lot that we don't have to worry about oversampling. So now 70% of these cookies are chocolate, and 30% of these are mint caramel. 30% of these cookies are mint caramel. It's a mint cookie with a caramel center. I'd try it, but I don't know if I'm even a fan of it. Now you're going to scarf down this whole plate of cookies. What would you like to occur? Walker, I want you to tell me, when you eat this whole plate of cookies, because we just have this plate of cookies right here, what would you like to occur when you eat this plate of cookies? What would you like to occur? And remember, it's not that 70% of these cookies are chocolate. It's that, like, out of the batch of cookies, which is a huge batch. So, Carson, I'd try that right there. All chocolate cookies. What's the probability that all of these cookies are chocolate? What's the probability that every single one of these cookies are chocolate? What is the probability that all cookies are chocolate? Any idea? Well, one cookie being chocolate is 70%. And then you got it. Walker's saying in the chat, nice job. 100,000 points right there. And to Carson and to Melissa. Thank you guys for being here. But if you have the probability that one cookie is chocolate and then all the cookies are chocolate, is raising it to the 6. Because the first cookie was chocolate and the second cookie was chocolate and the third and the fourth and the fifth and the sixth. So we have here that the probability all the cookies are chocolate. Now, would you agree with me, when you eat these cookies, either they'll all be chocolate or what? At least one will not be chocolate. So you're right, keyword and, you know the multiplication rule right there. Great job, Walker. It's good review. And so either all the cookies will be chocolate or at least one will not be chocolate. Either all the cookies will be chocolate or at least one will not be chocolate. So when we do this right here, we can see that we can do the following. And because just think about this. Either all of them will be chocolate or at least one will not be chocolate. And let's kind of read what this says. Everything but all 6 cookies are chocolate. Everything but all 6 cookies are chocolate. And I like to draw a number line for this. I'm going to draw my number line that I usually do to help explain this. The number line I like to draw has the following. You'll either get 0 mint caramel cookies, 2, 3, 4, 5, or 6. And you can see here that there's only 2 things that can happen if I draw it this way. Here, event X is where you get no mint caramel cookies. Here's where you get at least one. And this is everything that can occur. This is called the sample space. How you tell if and I'll answer that one next there, is the probability of one being not chocolate. Walker, so it is 1 minus 0.7 to the 6. Because I want you, once again, read it as you say it. Remember, this is, if you read everything as a sentence, always try to be able to read it. A chocolate cookie 6 times. Everything, because 1 is everything, but 6 chocolate cookies. Does that make sense right there? A lot of people make the mistake. What is this right here, which is a separate question? If we draw this in right here and we go 0.306 and then 1 minus 0.306. What is that? That's a totally different question now. And what would that be? What is, just think about what is 0.3 to the 6th power? 0.3 to the 6th power is getting what? Every single cookie was mint caramel. The probability of getting yes. And then the 1 minus would be there's at least 1 chocolate. Because remember, this is how many mint caramels we get. So if you look at this here is X and this is Y, because they're complements of each other, because this is everything that can occur. If you see me work a lot of problems like this, hopefully this notation makes sense. And when we switch it up, I'll show the other one again with the X and the Y listed on it, because that might help. Down here, at the bottom, we're showing how many mint caramel cookies we get. And now this is X, and this is Y. So let me put... So if you notice, now we're saying X is getting 0 mint caramel cookies, which means we have all chocolate cookies. And then Y is everything else. It's getting at least 1 mint chocolate cookie. Because the 0 through 1 is how many mint chocolate cookies we get. And then now when we do it this way, And then we'll do Melissa's question next here. Thank you, Melissa, for hanging out and asking questions. So now when we do it this way, we go X, we go Y, and this is X right here, because X is every single cookie, all of them, all 6 of them are mint chocolate cookies, and then Y would be at least one is not a mint chocolate cookie, which means there's at least one chocolate. So does this make more sense, Walker? Like doing it like this, I changed from light bulbs to cookies. I don't know. Now I just wish I had like cookie dough to make cookies. So that's right there. How do you tell if a sampling distribution is skewed or not? Usually in the problem, we just say it. Great question, Melissa, right there. It was good practice. Yeah, and this is a really great example problem. I like to switch it up. It's like a light bulb problem. And this is just the same as the light bulb problem. You can literally just change these to working right here and not working. So you can just change working, broken. And now it's the light bulb problem. And so this would be number broken down here. So now it's the light bulb problem written out, but it's just the wording changes. So whenever we do a sampling distribution, Melissa, great question on that. We usually just say it in the problems, like. I miss talking about Dave Ramsey every day. Should watch. I don't know. I've got so much spare time. Usually we just state it in the problem. That's what we do. We like Dave a lot. He's a great guy. So we draw the distribution. Here's slightly skewed. Here's really skewed. And then the numbers we need to know are the following: 1, 25, or 100. So we will state it in the problem. Dave is your fave? Cool. And so this is the shape of it. And it really is. And you can tell he really cares about the people. It's tough. And, people are going through tough times right now. So Melissa, we will definitely state it to you in the problem. And if not, you could view the sample. It's just really hard for us to do stuff like that on the test. But if you were to actually see it, so either we're going to say it in the problem, we'll say it's normally distributed, it's skewed, or it's very skewed. So you can see normally distributed, skewed, very skewed. So those are the differences right there. Or we might give you a histogram and you can look at it. So either it'll be stated for you in the problem, Melissa, we'll say it's normal, or we will show you a histogram of it. So you could see something like a histogram, and then you would have to, that's a horrible histogram, and then you would have to look at the histogram and garner from the histogram that histogram is mostly normal right there. So either stated in the problem, or you would garner it from the histogram. Does that make more sense right there, Melissa? And then you had a question about the practice test. Let me get the practice test up right here. So, or we could do one similar to it. So here's another version. This is a probability. Yeah, thank you, Melissa, right there. So now we'll go right here. And let me insert a table. Okay. So let me make up my own practice test question. So you're going to play poker. We're doing poker games now. Okay. So you're playing electronic poker, and can you guys see it pretty well on my screen? It looks like, hopefully everyone can see that. So we've got here however many simulations we have, and you're going to get a 5-card hand. And let's say, it's hard to do that with numbers. I'm trying to think of a really good way to do it. We could do it with the outcomes. It's 5 cards. It's hard to simulate 5 cards with. You can do it with numbers, but, well, sure, why not? Okay, ace is the lowest card in the deck, so an ace is going to be a 1. The remaining cards after 10 are jack, queen, king. So it should be 13 cards each suit. So here we go. This is just me making up a problem right here. And we're going to play electronic poker, and we're going to see how often we win. So many good things. Dow is up today. Well, that's good. Okay, so card 1. Let's go here. There we go. Okay, so now let's generate random numbers. I wish I could do it really easily, but we're gonna have to put them in here. Okay, so we're gonna just generate some random numbers. This is for randomness. This is a randomness problem. So this is a randomness review problem right here. So isn't there a way to... 2 seconds. I want to make this look just nice. So I'm going to work on this. I want to make it look... Is it this one? No. It's you click on this. I know I've done it before, and now I can't find it. Well, darn. Okay. It'll have to look like this. Let's do it. Putting some easy ones in here that we can at least identify. Whew. This is not a perfect problem because we're not worried about like flushes. Played too much poker in my day. So the key thing with any simulation problem is you want to be able to convert the numbers. This is the key thing for any simulation problem, is you want to be able to actually talk about what's going on here. So, okay. This problem right here has a little bit of a trickiness to it right now. We're just converting numbers. We're just practicing that. Whenever you get stuff like this, immediately start converting. Do you ever remember the rules I set up that the lowest card in poker is a what? So we really only need to do a little bit of converting right here. The lowest card in poker is a what? The lowest card in poker is a what? Lowest card in poker would be an ace, and we're just identifying an ace as a 1. It's also aces high too, but we're going to put ace at 1 just so we can generate numbers. There is no 1 in a deck of cards, so that's an ace. If you notice here, I'm just changing the ones that are aces right now, so I'm just writing in here my own notation to make these aces, so I can tell where the aces are at. What else do I need to convert? For anyone who's looked at a deck of cards, what else is not a number in here that needs to be converted? I know, I did that on purpose. I know. And then what's the 13? I was like, why not? And we don't know the suits of these cards. 11 and above need to be converted. So remember, it goes Jack, Queen, King. So this is a King. King is then after that, or Jack, and then Queen, and then King up here. So you can look at it and you can actually convert it. King is 13. Yep. So we just need to convert all of this into actual cards. That's the goal of this right here with any simulation, is to take numbers and actually do it. Now what you could do, it'd be really super complicated, is you could generate random cards from this. And actually, you know, I might do that real quick right here. It wouldn't be too hard to do. I'll show you how it works with randomness. 4 of a kind with King. I know, that's right. It's not the best hand, but what we could do, I wonder, let me hop over here to R and see how quickly I could do this. How quickly can I make a 5-card hand of poker? I wonder if I could design... I could write Texas Hold'em probably into this. Like, it'd be hard to make people play each other. I don't know. It's not as good without the internet. So if we want to go here to cards, cards have... or let's go to suits. So suits would be the suits of a card, or are clubs, and then spades, hearts, diamonds. So there's the suits, and then we have the face of the card. So the face of the card is going to be 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10, and hopefully it lets me combine these two together. So Jack, Queen, King. Let's see if it takes that. It does. It takes it. Good. And it's got this right here. Then I wonder if I can permutate. Cool. If I can permutate these two, because be string connect, but I want to do it where, like, let me try. It probably won't let me do this. Face times suits. Well, it's not that hard to actually do it. Wait, generating a random card's not that hard, because all I need to do is just go sample, and I'm going to sample, so I need to know the, yeah. So let's go to face of the card. I'm going to take a random sample of the face of the card. So let's just say this is card 1 right here. So this is card 1. We need its face. We need card 1 face. Don't do that. Card 1 face. And we need to sample from the face one card. Or, you know what we could do? We could just do cards as a whole. So there's my cards, cards face, and there it is right there. And then we sample 5, replace equals true. And here's my 5 cards, and then we need the card suits. So we're just gonna get here cards suits, and then we sample 5 suits, and then here's the suits right here. Oh, we do have an issue though. We can get the same card twice. I might do more stat to 1 examples here in a moment. I want to make a list of all the cards, and that's what I should do because we can't get the same card twice. This could lead to us getting the same card. Like this could have been 2 of diamonds at the end. It's theoretically possible. It's not likely. It's possible, but we don't want that to occur. So I really need to do my string connect, and I need to get better at library string R. So I need to like connect all the strings. I don't want to write them all out. By the time I know how to do this, it's like going to be the same as writing them all out. So, and I feel like I'm boring people. It's like, oh no, how quickly can Ryan do this? Because I can't just go suit times faces because they're not, yeah, that's what I thought. It's not the same type of argument. It should, you can use rep. Oh, I know what to do. I know what to do. That's it. Okay, I got it solved, I think. I can rep the faces of the cards 4 times. And that'll give all the faces 4 times. So then I need to then go here and do this. Suits. Well, put it back where it was. And I need to go here to concatenate a vector, rep, clubs, 13 times. Let's repeat this. There we go. And yeah, cool. Rep that 13 times. And then that. Rep diamonds, hearts, spades. Oh, thank you so much. Anytime. We'll have some more fun. I know it's winding down. I'm just kind of having fun right now. And I'm going to make this look a little bit nicer right here by going to this and rep this inside of here. If my mouse would stop being crazy, I swear it's... I don't know why it's been doing that lately. Okay, so that should do it. We should have all the suits. Yep. We should have all the faces. Whoa. What happened? Rep this. What? Well, that's what happens when you change something that's working. Let's not break this. Let's just do that. There we go. Okay, and then we'll store this with face right here. Okay, now we just need to connect them. So we need to use like string, is it str connect, string concatenate, see, you guys are too funny in the chat. String extract, string replace, string to sentence, I think it's string C. Joins 2 or more vectors into a single character, optional. And whenever you don't know how something works, you can usually go to F1 and then it shows you how to do it. It's over here on the side. And they have examples down here at the bottom of how to use it. And so, missing inputs, I think, yeah, so these are the examples over here on the side that I'm looking at how to use. I think I want to use string concatenate. Let's see what happens. It's probably not going to like it. Oh, because it's not faces. When will I ever learn? Oh, what do we got? Yes, let's put the face first. And I think I can put something between them then. Is there more than there should be? Oh my gosh. You guys, you got to remind me. I forgot something. Mouse, stop being crazy. Ace. There we go. Okay, good. Good thing an error message came up. And then, is there a sep on this? Please tell me there's a separate. Yep, there's a sep. No, what am I doing that? Sep equals dash. There we go. There's every card we got. So ace of spades, all this right here. So now what we're going to do is we're going to call this cards right here. And the mouse is going to stop being crazy. I think it's my multi-screen setup. Wow. Okay. We'll go here, we'll go to cards, and we'll do this. There's all the cards. We have our cards made. And now we're going to go here, and we're going to go to sample, cards, 5, and replace equals false. And guess what? We get 5 cards. There's our 5-card hand. That is a true randomness right there. We can just keep making 5-card hands, and we could put this into a list and just keep seeing. Ooh, we got, what do you think about this? Wow. Walker, look at that hand. You still here, Walker? I don't know if Walker's still here. Did I lose everybody? I don't feel bad. I have like 0 people. We had 4 or 5. We still have 5 people. Wait, stream health, 5 people watching. Good. We're still at 5. How does that last hand look to you there, Walker? Do you want to, this is my hand, or Walker, do you want this to be your or my hand? Walker, do you want this hand, or do you want me to take the hand? Look at this hand we just drew of cards. What do you think about that? It's almost a full house. Was the one before that a full house? We have 2 kings. It's 2 of a kind, I think. Okay, so you've got 2 of a kind. Here, I'm going to draw a hand. You ready? I want the full house. Oh, look at that. That is so close to a straight. Oof, that's a bad hand. 2 queens with a 9. We got to look at the suits also. But if you can see, we can get a 5-card hand pretty quickly. So we get some pretty good hands. We could design this so that you could, like, you know, if you keep writing this program as you go, you could have it so that you could, you know, replace your cards. So you would just store this sample as like my hand. So this would be stored then, and you could literally look at like the second card in your hand. So the second card is this, and someone could like remove the second card, and you would just go to second card in the hand and do this. And then if you look at the person's hand now, they won't have a second card. So if you look at that right there, and this is why I love programming. If you just think about how it works, it's like you're just taking that card out of the hand, and then you would replace that card with a sample. Now we probably need to keep updating the sample because we need to remove the cards. So we make this more complicated as we go, but I could literally turn this into a function where you could ask someone, like, you could draw a hand, I could give you a hand, and we could play it. It'd probably take another 30 minutes. So I might not do it too much longer. Does anyone have any? We lost a viewer. Oh, no. We're kind of just winding down. I'll probably be back later. But what do you think, Walker? What do you think about our Twitch ideas? Like, tomorrow after class, what if we all went to Twitch? Like, if I said, hey, after class tomorrow, and I want to do interviews and stuff. Maybe I'll ask, I know one person will do an interview. They might do it like after the semester, but they're not doing much right now either. But if anyone knows, I heard Peyton Manning like appeared in a class. If anyone knows anyone, we could do, I've still got my interview table open. So I've still got this right here. It doesn't look as, if I was behind the green screen, it might not look too bad. But and let me actually, there's a thing I can change. Oops, I grabbed the wrong scenery there. Did I undo that? Okay, good. Let me see. There's something I need to do here. I'm going to work on this real quick. There's that interview background. Did we put in the background? Main screen capture. Whoa. Did Jason fix this or did I fix this? Maybe I did fix it. All the things we fix that, there's so many little things. And thank you to Jason. I miss doing work with Jason. Go there. And here we go here. Let me put this behind it now. So this needs to go behind the interview background. There we go, right there. Maybe I should have kept it the way it is. Can I Control Z undo? And maybe it looks pretty good right there. I'll be. Anyone who would want to get interviewed, I can put them on the big screen here. There's a lot of ways we can do this, but it works. The effect looks better when I actually have the green screen. So, but yeah, we've got a whole bunch of buttons right here. Oh, we just went away. Speedrun we haven't been using as much lately, but we'll do more speedruns. I feel like the screen sizing, oh, I know why. Because of the way it's sized. Oh, there's the intro. Here's lecture. Oh, there's randomness currently going. I'm just clicking every button. But if someone wanted to talk about statistics, I like talking about sports and how sports use statistics. But we could also, and I think to get an athlete on here would be really cool. So if anyone knows anyone who has any connections, like if an athlete's like bored right now and they're like, hey, I wouldn't mind talking to a stats class about sports and statistics. If you know an athlete, want to get them on here, want to get them talking about it, we love talking about how sports use statistics. Does that make sense there, Walker? So all of these streams always end with me being kind of pretty random at the end of these. But I think that's got it. Cypher, but yeah, if you have any questions, feel free to ask. I might get on here later. Appreciate you being here, and I'm going to answer some emails, but so good seeing everyone. I'll talk to you guys later, and keep up the positivity. You guys are doing great.